So now I'd like to introduce our keynote speaker. Mike Grandinetti is a serial entrepreneur, board member, AI and innovation consultant, professor, and executive fellow at Harvard Business School. Mike is a graduate of the Yale School of Management, where he was named the annual Jess Morrow Johns Memorial Scholar and was a recipient of the annual Procter & Gamble Leadership Award. He's taught courses on entrepreneurship, product design, social innovation, leading innovation strategy, creativity, critical thinking, human-centric design, and transformative leadership. He's been named Financial Times Global Professor of the Week and Professor of the Year on multiple occasions. He's led over 200 hackathons and design sprints globally for corporations including Accenture, Capital One, IBM, Microsoft, Nestle, and Nike, and for impact organizations, including the MacArthur Foundation, Design for America, and the Women's Sanctuary Rosie's Place. He served for over a decade on the WGBH Public TV and Radio Corporate Executive Council. Today, he's deeply engaged in AI executive education on a global scale by teaching courses at Carnegie Mellon, NYU Abu Dhabi, Oxford, UMichigan, and Babson across 5 continents. He's on the faculty of both the Cornell Chief AI Officer Program and the Cornell CXO program. He's a long-serving organizing team member and senior advisor to the MIT CIO Symposium, where he regularly moderates panels and gives talks. He serves as a judge in the annual MIT CIO of the Year Award, and he's a frequent keynote speaker and has delivered several TEDx talks on entrepreneurship and AI. He enthusiastically mentors the next generation of young founders in several of the world's top startup accelerators. So at this time, I am happy to introduce Mike, who will now give our keynote presentation.
Charlie, thank you. And can you hear me?
Yes, I can.
So first of all, it is an honor to be able to address you this morning at an incredibly consequential time in the history of computer science education. I think we all know just what an extraordinarily dynamic and anxiety-producing year we have seen so far, and we're not even done with the year. And so just a little bit about my background. I know that we had a very broad overview, but I spent 25 years in Silicon Valley building 8 enterprise software startups, and was fortunate enough to have taken 2 public and have 7 acquired by large entities like IBM, AT&T, and Oracle, right? So I've been living in this industry, and of course, I've got an undergrad in engineering and a minor in computer science. So this has been the world that I had been living in, both as a practitioner, before that as an engineer in Silicon Valley, and then very recently, over the last, not very recently, the last 20 years, as an educator in some of the top schools in the world, engineering schools as well as business schools, and have led over 200 hackathons and design sprints. In this past year, probably 10 vibe coding sessions. And so let's talk about the software industry. The software industry is obviously asking some pretty important questions right now, right? One is, if AI can write working code, what is the point of teaching programming? And I think we all know the answer to that. What should computer science mean for a 13 to 17-year-old student today? And how do we as educators go about helping, mentoring, supporting our students and ourselves as well, so that we thrive in this profound transition and not fear it? Okay. And so the question for each of you is, are you self-aware, and which one are you? How do you see the changes that are happening? And a lot of it is going to come down to mindset. So as our sponsor just mentioned, coding should be joyful. And so I have the privilege every summer of teaching a course at the Harvard Summer School to 25 extraordinarily bright high school students, typically rising sophomores and juniors. And almost exclusively what they have told me over the last 3 years is AI is more or less forbidden in their classrooms. And when I let them know at the beginning of the first session that we were going to be vibe coding applications that would address problems that were of importance to them in their generation, it was as if Christmas, New Year's, the 4th of July, and Thanksgiving were all rolled into one day. And I think the joy on their faces is self-evident. One of the student teams, and every single team, 5 teams of 5, wound up defining what problem they wanted to solve, defining how they wanted to solve it, and then building apps and shipping apps in literally 1 week, right? They did a lot of upfront problem definition work, but by the time we taught them vibe coding, they had about a week to stand up their website. And in this specific instance, it was a group of 4 young women, all whom shared what they felt and what they validated was a very universal challenge, being overwhelmed with a lot of conflicted influencers telling them what was good for them. And so this was a quote from Laksha, right? The ability to learn how to take a problem, transform an idea into a solution, and then create a functioning product. And to have the agency to do that. And so I think for all of us as educators today, we need to step beyond what we would consider to be more mindless coding and provide our students with the ability to think a lot more comprehensively, a lot more strategically. And so within the context of the classroom, I actually see this transition as a positive. I actually see this transition as something that is going to allow our students to have more fulfilling careers as we train them to be more well-rounded citizens. So the great Paul Graham, the founder of Y Combinator, talks about making something people want. Often people writing code are being told what to write, what code to write. They're not really involved in the strategic discussions. And there's no question that we need to take both faculty within our high schools and our middle schools and our students and allow for a breakdown of silos, right? We need a lot more cross-disciplinary activities. Aalto University in Finland always named year after year the country with the most innovative capacity of their graduates, figured this out 25 years ago, where they collapsed silos, where everything is done in sort of a multidisciplinary way. And the results have spoken for themselves. We're going to need to collaborate with our colleagues in other departments. And it's something that cannot happen soon enough. Okay. So we hear an awful lot about the importance of critical thinking. I certainly have noticed a decline in critical thinking in many of my students as they have been doom scrolling on TikTok. And I think this is a vitally important thing to bring back into computer science classrooms. I think the ability to really identify very meaningful, societally critical problems that are worth solving, and to then begin to think about how we structure a solution to that problem, right? Because at the end of the day, we can only solve problems that we understand. And we can only understand problems by talking to our stakeholders. And these are skills that I think are really critically important for every computer science student, regardless of what classroom they're in or what level they're at, to be able to learn as early as possible. Okay? And we need to teach them empathy, right? So a lot of these soft skills are incredibly powerful when combined with harder skills like data science, computer science, AI. And so sharing with our students a very critical lesson that there is no such thing as failing, that it is nothing more than a first attempt in learning, and giving them the opportunity to learn how to iterate, fail, learn, and move forward. And so finally, before we move into where I think we're heading, the ability to help them understand the value of both divergent and convergent thinking as they begin to think about solving some of these meaningful problems, right? I can tell you from experience as an educator for 23 years that this is where students get lit up in the classroom. This is where the transformation happens. This is where the epiphany happens. When we give them agency to work on problems that matter to them with people that they want to work on with. And so we've seen this movie before, right? We're living through now the 6th wave of innovation. Schumpeter, the great Austrian economist, coined creative destruction. And so this is a pattern that we have observed throughout history. And it's coming at us yet again. And we have the ability, we have the agency to react and see it as an opportunity or to see it as a threat. Okay. And so let's go back in history very quickly. The first 4-year computer science university degree program is only 60 years old. It's still a relatively new field. And yet in 2011, the great prophecy by the Silicon Valley venture capitalist and entrepreneur, Mark Andreessen, talked about software is running the world, eating the world. And that's more true in 2025 than it was in 2011. And that's never going to change. Okay. So we have lived as computer scientists and as educators of computer science through immense change. Just look at the number of new languages that have been created throughout history up to 2009. And then in the modern era, right, even more rapid acceleration of change. So this is something that we've been able to manage since the 1960s. And there's no reason why we can't manage this change going forward. Okay. Now, there's no question that we have seen some profound innovations come into our worldview. Okay. And the rate of change that we've seen of these foundation models has been nothing less than jaw dropping. Okay. I'm sure many of you have heard about the recent International Collegiate Programming Competition and the fact that 3,000 universities around the world from over 100 companies who come to compete every year from the best computer science programs in the world competed against OpenAI's Codex. And OpenAI's Codex was the only quote unquote team, although it was a robotic team, to actually get all 12 problems correct. I'm sure many of you have heard the increasingly breathless reviews about Claude Opus 4.5 that have been blowing up X or Twitter over the last week or two. And, these incredible pronouncements that even very, very senior level programmers are now programming almost entirely in English. I get it. Okay. And we know that this is only going to continue in the years ahead. But innovation, including the ability for us to react to these destructive types of disruptions like Claude Opus 4.5 or Google Gemini, we need to look at them as an opportunity, not a threat, to rethink how we are educating our students. And so the illiterate of the 21st century are those who cannot read, is not going to be those who cannot read and write, but those who cannot learn, unlearn, and relearn. I know that I have had to completely relearn how I teach and how I assess my students. And as someone who has been, in the digital world for my entire career, the thought that I would ever bring back blue books to test my students is something I would have never dreamed of even 2 years ago. But here we are. The fact that I can no longer assign my students Harvard Business School case studies to read the night before a class because I know that there's no way they're going to read them. They're going to get an answer off of ChatGPT. Everything about the way I teach has changed, and that's fine. As educators, we need to model our behavior and we need to adapt. Okay. So how do we reskill both ourselves as well as our students in this new era? Okay. So I think we all know this, what's really changing, right? We're going to see these type of tasks increasingly automated, right? And so as I've previewed before, right, our ability to make a difference in our students' lives and to prepare them for their universities and to prepare them for their careers, we need to help them learn how to frame problems, design systems at a system level, and reason with and challenge AI. Okay. What has not changed is Andreessen's prophecy. Software and data-driven systems will become increasingly more pervasive. And so we need more and more people who understand context, trade-offs, and failure modes. And so we need to be aware of the gap between these two extremes. Okay. So what is the emotional reality for CS teachers, right? We know that students can now bypass the struggles that built our own expertise. I was not allowed to use a calculator in my 4-year engineering and computer science degree. That's a different world, right? We know that parents and the media are questioning the value of CS, right? We know that assessments are getting harder. They require more time, energy, and effort. And we worry, are we preparing students for careers that might disappear? And I would say emphatically, no, they will not. Okay. So K through 12 computer science frameworks and CSTA standards, right? And we're going to see so many recommendations that I think we really need to thoughtfully embrace sooner rather than later, right? But we need to continue to emphasize core concepts, including data, algorithms, programming, impact. We've got to be much more language agnostic, right? And focus on computational thinking, communication, and collaboration. And we've got to align with approaches in this new AI era that are about concepts and not specific syntax. So, what are some of the signals that we are receiving from code.org? Right, they are now rolling out this Computer Science and AI Foundation course, which is a free high school course with no prior experience needed. I would think that you would want to promote this kind of opportunity for your students. And let me say here, I think that this actually expands the pool of students that want to study computer science in high school. We all need to become builders, right? And AI is getting a level of media attention that has been just unprecedented. And we're starting to see more and more students wanting to participate in vibe coding sessions. And so I would think that we would want to use this as an opportunity to encourage many students, even outside of our computer science classrooms, to experience this and have them fall in love with the idea of building. Okay. And so obviously code.org did an amazing job with their Hour of AI initiative, 500 million hours. Okay. And we're going to start to see this moving forward into the world of AI as well. So what are some of the challenges that I know many of you are facing based on my discussions with educators, right? Many of you are frustrated because you're being forced to teach AI without computer science expertise or guidelines. Okay. And so obviously it's very, very difficult to teach something that you yourself haven't been trained in. And then if I go to X and I ask if I go to Grok and I ask them, how are teachers feeling about the current situation? Right. On the one hand, what I'm seeing is schools want AI literacy, but 60% of districts are providing no guidance. And I've heard that repeatedly from colleagues of mine as well, but this is consistent. Teachers are being asked to teach what they don't know. It's a recipe for failure. Okay. And so as we move into computer science education weekend next weekend, we have an opportunity to really reset the way that we think and engage with our stakeholders. Okay. What are some of the signals from top computer science programs at the university level? Well, they are certainly not abandoning computer science. They are simply redefining it, right? AI fluency, ethics, system level thinking are now being built into the core. And AI is being treated as another engineering discipline, not some magic add-on. Okay. What is the competency framework at the heart of ACM AIAA 2023, which of course is the update from the last decade? We're replacing hours and topics with measurable, professionally relevant abilities that combine what a student knows, what they can do, and how responsibly they can think, which is exactly what industry and society now demand from CS graduates. And I know I've hired many, many hundreds of computer science graduates in my career as a C-suite executive of an enterprise software startup. And in the past, those skills were rare, and they should not be rare. Every single computer science graduate should be able to manage that. Okay. And so we're starting to see new degrees. MIT has its second most popular degree now is about society, ethics, and the profession, right? And so the old model is that CS 2013, it's a knowledge-centric approach. Students will learn recursion, and they're assessed on the topic list and the number of hours they spend, versus the competency model that students will analyze and debug recursive solutions to real-world problems, and that there's a measurable learning outcome in a rubric. Okay, what is the benefit of this competency framework? These are approaches that support alternative pathways. It could be a massive online course. It could be an internship. It could be a project. It could be an externship. It could be all of the above, right? And it directly aligns with the Accreditation Board for Engineering and Technology's 2025 accreditation recommendations. Ethics and dispositions now become much more accessible. And we're able to create competency-based transcripts and micro-credentials, which will only serve students looking for internships, jobs, and admission to the top computer science institutions in the world, okay? How are some of the top universities using CS 2023? Carnegie Mellon has already created a new CS Academy with competency badges, and students are earning micro-credentials for each of their specific competencies. University of Illinois is piloting competency-based transcripts, so student can graduate once all core competencies are demonstrated, even if the course sequence is different. Georgia Tech and UCal Berkeley have redesigned a lot of their programs to address and assess the exact AI ML303 competency from above, right? So the top universities have responded. And as we all know, universities don't change easily. So they have been remarkably agile in a very short period of time of stepping up and recognizing how profound these changes are. And I think that's good news for all of you as your students graduate into these programs. The key is, are they prepared to succeed in these competency-based programs going forward? Okay. And so MIT's brand new decision-making course is now this number 2, decision-making in AI is now the number 2 major at MIT. Georgia Tech is embedding AI into many of their core courses. They're creating maker spaces now for hands-on projects, right? So everything is about experiential learning. Okay, I'm going to skip this one. And so the future CS graduate is AI fluent. They're able to use, build, and critique AI systems. And you as educators are able to help students lay the foundation for these skills, these competencies, and these capabilities. Okay. So what are the 4 big shifts, right? We're moving from syntax to solving problems. We're moving from being solo coders to collaborative human-centric designers. We're moving from black box AI to critical ethical AI literacy. And we're moving from a fixed curriculum to competencies and projects. Okay. So shift number 1, moving from syntax to problem solving, emphasizing decomposition, algorithms, data modeling, and testing, where we let AI draft code, but we require explanations. We test the design, we refactor our decisions. And we grade the thinking process, not the presence of working code. I've made this point, and in the interest of time, I'm going to skip number 2, shift 3, the ability to really understand bias, why hallucinations occur, how privacy needs to be managed through concrete, relevant teen examples. And we set norms, we disclose AI use, we verify outputs, we never paste untested code into projects. And so I'm starting to see a lot more students at the university level choose to major in 2 majors simultaneously. So it could be that they're majoring in the cognitive sciences, they're majoring in philosophy, they're majoring in the creative arts, they're majoring in literature, they're majoring in music. And so I think there's an extraordinary level of power when you're able to bring both right brain and left brain thinking together. And I think a lot of that can start, a lot of the desire to be able to do that and appreciate and recognize the power of it happens within the K through 12 pathway. So I'm going to finish up by talking about code sense. And of course, this is your own framework, the CSTA framework. Okay, the era of syntax modernization is so over, right? In this new vibe coding revolution, we've got to evolve to systems architects. And so there are 6 distinct pillars in code sense. And here we have a spider diagram showing what the different competencies are on these 6 different axes, and showing where in gold a novice vibe coder would be able to succeed. And then much more importantly, where a proficient code sense coder needs to be able to operate in order to be effective. And I'm assuming that most of you, given that you're here on a Saturday morning, are at least aware of some of these recommendations. Okay. And so this is an area where we have a fairly significant gap between code comprehension and debugging, right? So novices can certainly generate code, which is a high level of orchestration, but they're not necessarily able to either explain the code themselves or to debug it when it breaks. And so code sense is requiring a balancing of all 6 axes, okay? And so the workflow goes from decomposition, breaking vibe into technical specs and logic flows, orchestration, where we're prompting a junior developer to generate code blocks, auditing the code, and then integrating it, stitching different components together into a working system. And then to efficiently and effectively grade a project that has been vibe coded, we can't just grade on the final file. We've got to assess the process. This is exactly what I've been doing in my own courses for 23 years. There's always a capstone project, and students are graded on milestones along the journey. And while the final deliverable is certainly important, it's their thought process, their logic path that is equally important. The way they've collaborated as a team, the way that they have engaged in the classroom and expressed curiosity to learn and grow. Right? So it's a much more comprehensive, much more holistic assessment, a much more fair assessment. Okay. And so there's now this method, which is kind of the sandwich method. The top of the bun is the spec itself. The deliverable is a system design document, right? The students must understand and draw out the logic flow, right? Does this logic make sense? The meat in the middle of the sandwich, the generation log, and you're delivering a prompt history. Did they steer the AI back when it hallucinated? Did they refine the prompts? And then the bottom bun is the defense. The deliverable is a live code review. Can they in real time explain complex blocks of thought and logic in their own words? What does line 42 do? And so questions to determine if a student possesses true code sense or is merely operating the machine. Okay. And so what are some things, and I realize we're less than 30 days away from the end of the year, but what are some of the things that we can wrap our head around this year as we work our way through this conference this week, computer science education weekend next week, right? How do you begin to think about rewriting a few key learning outcomes for your courses going forward? How do you add specific AI policies to your syllabi? What is allowed, what's not? How do you create at least one AI augmented assignment where critique and testing are graded? How do you include at least one unplugged or low-tech activity in each unit to deepen concepts? And how do you collaborate with colleagues and leverage CSTA and ACM resources for assessment and policy? Okay. So let's be clear. There's a lot that will remain non-automatable, right? Curiosity is what makes us human. Values, judgment, a sense of responsibility for others is what makes us human. That will not go away. We need to tease out and reinforce these human skill sets, these human characteristics and capabilities, the ability to work across differences, build things with people, not just for them. And you, as educators, as mentors, right, are role models for this type of behavior, right? So a hopeful reframe: coding is anything but dead. Coding will remain an incredibly critical skill set. K through 12, CS is where students to learn about and fall in love with coding. The unique value that you all bring as educators is to model curiosity, judgment, and care in how tech is used. And you're preparing thoughtful tech leaders, not just future coders. Okay? So I'm going to ask you to just take 30 seconds between the time that I wrap up and the time that the next speaker jumps on to think about one thing that you will stop doing in your classroom and one thing that you'll start doing on Monday. I want to thank you all for the extraordinary work that you do to support, inspire, mentor, and educate our students, and for the contribution that I know all of you make to the future of our field. And many of you probably are familiar with this, but for those who aren't, the Hour of AI is now something that is being promoted by code.org to supplement what has been an immensely successful initiative with an hour of coding. And there's an hour of vibe coding that is happening in the next week that is being promoted by code.org and Wix. And I would recommend that you make sure your students are aware and have the opportunity to decide whether this is something that they want to participate in. Okay. So Charlie Darwin said it best: it's not the strongest of the species that survived or the most intelligent, but the one most responsive to change. And I do think that this is a time of profound change. And it's up to us as how we respond to change. So thank you for your attention, and I wish you a great conference, and I thank you for inviting me to share some thoughts with you.